Imagine being told that an entire species had only 51 survivors left on Earth. In 1995, New Zealand faced exactly that nightmare with the bizarre, flightless Kakapo. Scientists moved every remaining bird to remote islands, believing they had saved the species. But what happened next shocked everyone. The birds simply stopped breeding. For years, nobody knew why. The answer would reveal one of the most extraordinary conservation mysteries ever solved.
If you liked the video, make sure to like, share, subscribe, and stay with us for more.
The Kakapo miracle. The Kakapo is the strangest parrot on the planet. It cannot fly. It weighs up to 4 kilograms. And it has a distinctive scent that people describe as a mixture of wild honey and tree resin. By 1995, only 51 of these remarkable birds remained on Earth. The New Zealand government made an unprecedented decision. They evacuated every single surviving Kakapo to remote predator-free islands. It was a desperate gamble to save a species on the brink of extinction. But then something unexpected happened. Under these artificial sanctuary conditions, the Kakapos simply refused to breed. To understand why, we need to look at what makes this bird so unusual. The Kakapo is the heaviest parrot in the world. It can live up to 100 years. Unlike other parrots, it is flightless and lives on the ground. Its green plumage provides perfect camouflage in the mossy forests where it makes its home. These adaptations served the Kakapo well for millions of years. New Zealand had no land mammals for 60 million years. The Kakapo evolved without natural predators. Its response to danger was to freeze and rely on its camouflage rather than flee. The distinctive honey-like scent helped individuals find each other for mating. But when humans arrived and introduced mammalian predators like feral cats, rats, and stoats, these same adaptations became fatal liabilities. The Kakapo's instinct to stay still when threatened made it an easy target. Its strong scent allowed predators to track it down. By the 1970s, conservationists feared the Kakapo was extinct. Then in 1974, an expedition discovered 18 males living in remote valleys. This was both hopeful and devastating. All the birds were male. There were no females to breed with. A female population was later found on Stewart Island, but predators were rapidly hunting them. The situation was critical. In 1995, conservationists made a historic decision. All remaining Kakapos were removed from the wild. 51 birds were airlifted by helicopter to offshore islands where predators had been completely eliminated. Strict biosecurity measures were implemented. Every piece of equipment entering the islands was sterilized. Nothing was left to chance. The birds were protected and carefully fed. But between 1980 and 1995, breeding success was abysmal. Only 3 chicks survived. Initially, conservationists thought rat predation on eggs was the problem. They eradicated rats and enhanced nest security. But then the birds refused to nest altogether. They appeared healthy and well-fed, yet they showed an unexplained reluctance to reproduce. The sanctuary conditions that were supposed to save them seemed to be suppressing their breeding instincts. This was not the first time such a strategy had failed. In 1894, a conservationist named Richard Henry moved approximately 400 Kakapos to Resolution Island. It seemed like a perfect solution, but in 1900, stoats crossed over from the mainland. They wiped out the entire population. This historical failure influenced the 1995 program. The chosen islands were far from the mainland. They were meant to be completely safe, but the birds still would not breed. Scientists spent years searching for answers. They analyzed everything about the Kakapo's natural environment. Finally, they made a breakthrough discovery. The Kakapo's breeding is triggered solely by the fruiting of the rimu tree. Rimu trees produce large fruit crops every 2 to 6 years. The fruit contains high levels of calcium and vitamin D3. This was a remarkable finding because vitamin D3 was previously believed to exist only in animals. Now it was confirmed that this plant synthesizes it. Female Kakapos need vitamin D3 from rimu fruit for eggshell formation. During their long solitary incubation period, they do not eat. If they have not consumed enough rimu fruit before nesting, they cannot form eggshells. The females physiologically refuse to nest. This explained why the birds in the sanctuary were not breeding. They were missing the critical environmental trigger. In 2002, a major rimu fruiting event occurred on Codfish Island. This created a natural breeding window. Conservationists provided high-quality supplemental food, hoping that better-nourished females would lay more eggs. A new generation of chicks was born, but then another problem emerged. 70% of the chicks were male. This aggravated an already critical shortage of females in the population. The sex ratio was dangerously skewed. Scientists studied this phenomenon and found an explanation. Male kakapos are 30 to 40% larger than females. They require more energy to raise. Mothers in nutrient-rich environments tend to produce more males. This is an evolutionary mechanism. Producing male offspring maximizes their competitiveness when food is abundant. The solution was unexpected. Conservationists implemented nutritional control. They reduced food rations to keep females healthy but prevent excessive fat accumulation. This adjustment normalized the sex ratio to approximately 50% male and 50% female. The 2002 breeding season saw a population increase of 39%. This demonstrated the power of understanding and manipulating natural biological processes. By 2005 and the years following, the population gradually increased. It surpassed 100 individuals by 2008 and 150 by 2009. All nesting activity aligned with Rimu fruiting years. However, the population faced a new challenge, a genetic bottleneck. Only 36 genetic lines remained. Conservationists implemented innovative strategies. They replaced eggs with three-dimensional printed artificial eggs. These eggs were equipped with tiny speakers that played chick sounds. This psychologically prepared the mother for hatching while allowing conservationists to control the incubation process. This blend of simulation engineering and biology gained global attention. Artificial incubation allowed mothers to conserve energy. They could then lay second clutches during heavy Rimu years. The strategy proved remarkably effective. In 2019, 30 females nested twice, leading to a record 73 fully feathered chicks in a single season. The technology allowed the population to grow while maintaining genetic diversity. Each kakapo has a unique character. The most famous is Sirocco, a male kakapo who famously attempted to mate with an ornithologist's head during a live BBC broadcast in 2009. The incident made the species internationally famous. Sirocco became the official ambassador for the species. He is the only kakapo allowed to interact with humans openly. His personality and charm helped raise global awareness about kakapo conservation. Despite all these successes, threats persisted. In 2019, an outbreak of aspergillosis, a fungal disease, affected the population on Codfish Island. 21 birds were infected and 9 died. The response was immediate. All 51 birds were evacuated back to the mainland sanctuary. This was a symbolic echo of the original 1995 evacuation. The emergency move prevented further losses. A mainland sanctuary called Manga Tatara was established. It featured a predator-proof steel fence spanning 50 kilometers. However, the kakapos showed their adaptability. 6 of the first 10 kakapos escaped by climbing the 2-meter fence using their beak and claws. This demonstrated that the birds were active participants with their own behavioral strategies. The fence was modified, and the birds were returned. The Kakapo conservation effort spans generations. One of the most poignant stories is that of Richard Henry. He was the last representative of the Fiordland genetic line. His descendants now help maintain genetic diversity. Recent breeding seasons achieved remarkable milestones. 80 nests were established. 256 eggs were laid, 95 chicks were produced. This represents a historic high. The female breeding population rose from 20 in 1995 to 83 currently. The total population is approximately 247 individuals. Every bird is actively monitored using positioning systems and biological data tracking. The Kakapo recovery illustrates a fundamental lesson. Successful conservation requires understanding natural ecological and physiological cues, rather than imposing artificial conditions. Adjusting nutrition and timing conservation efforts with the Rimu fruit cycle allowed the species to recover gradually. The ultimate goal is to reduce human intervention. The aim is to restore the kakapo's natural ability to survive independently in old-growth forests. Challenges remain. Disease outbreaks and climate change pose ongoing threats, but the current population stability offers a strong foundation for future restoration efforts. The Kakapo's story is a compelling reminder of human responsibility in correcting past environmental mistakes. It demonstrates that species can recover when we commit to understanding and respecting their needs, from 51 individuals to nearly 250, from 3 surviving chicks to 95 in a single season. The Kakapo recovery program stands as one of the most sophisticated conservation efforts in history. It combines cutting-edge technology with deep respect for natural processes. The Kakapo is no longer on the edge of extinction. It is on the path to recovery, and that is a story worth telling.